Mayday, mayday. We're declaring an emergency.
6456, heavy turn right, heading 030.
In order to control the aircraft, the pilot uses gyroscopic instruments. Let's explain. Any spinning object displays gyroscopic properties. A gyroscope is a high-density, weighted disc that rotates at high speed with low friction. The gyroscopic instruments include the attitude indicator, the turn coordinator, and the heading indicator. Gyroscopic instruments can also pitch, bank, yaw, and heading. Imagine flying in cloud and having nothing else to rely on apart from your view outside your window, which is now gone. Without having instruments, most pilots would lose control of their aircraft in cloud within 2 minutes. A spinning gyro displays two interesting properties. The first is called rigidity in space. A gyroscope remains in a fixed position in the plane in which it spins. An example is a spinning top, which gets more stable as it gets faster. Another gyroscopic principle is precession. This refers to the tilting and turning of a gyroscope in response to a deflective force. The reaction does not occur at the point where the force is applied, but instead 90 degrees later in the direction of rotation. The rate of precession is directly proportional to the force applied and inversely proportional to the speed of the gyro. A good example of precession can be seen in tail dragger aircraft. As you can see, the prop normally spins right. As the aircraft accelerates down the runway and the tail wheel moves off the ground, this changes the angle of attack. This has the effect of an upward force. Precession means that the force will act 90 degrees from the point at which it was applied. The aircraft will yaw to the left as a result. Most pilots have experience of using right rudder to correct for the gyroscopic effect of a spinning propeller to keep the aircraft on the centerline. Precession can create errors in some instruments, for example through bearing friction. Certain instruments must be corrected every 10 to 15 minutes or so to account for this, for example the heading indicator. This adjustment is usually performed using the aircraft's magnetic compass and should only be performed when the aircraft is in stable, level flight. Gyroscopes are either electrically driven, such as the turn coordinator, or vacuum driven, such as the attitude indicator and the heading indicator. This means that there is always a redundancy, so if one system fails, the pilot can always rely on another system. Now let's explain how the attitude indicator works. The attitude indicator is used to show the orientation of the aircraft relative to Earth. The attitude indicator consists of the following parts: the artificial horizon and miniature aircraft, which can be brought up and down relative to the pilot's line of sight. The outer rim includes tick marks of 10, 20, 30, 60 and 90 degrees of bank. Above and below the horizon there are hashes in 5 or 10 degree increments. At the top of the AI there is a small object which indicates the actual angle of the aircraft's bank. In the vacuum driven instruments, air is driven through a filter and then through the instruments to spin the gyros extremely fast. It's important that there's enough air suction to spin the gyroscopes fast enough to get an accurate reading. This is displayed for the pilot on a suction gauge. The average reading should be between 4.5 and 5.5 inches of mercury. The AI's gyro is mounted in the horizontal plane. It relies on the principle of rigidity in space to function. There are two gimbals. The instrument responds to their motion, showing the attitude of the aircraft. If the pitch and bank limits of the aircraft are exceeded, it's possible to topple the gyro, so that will give an inaccurate reading because it has fallen out of its plane. The pilot should be familiar with how the AI corresponds with the aircraft's banking and pitch. For example, level climb, climbing left bank, climbing right bank, level left bank, level right bank, level descent, descending left bank, descending right bank. Nowadays, most aircraft include an attitude and heading reference system over the conventional gyroscopic instruments. Gyroscopes are used with an accelerometer and measurements of the Earth's magnetism, which results in an essentially drift-free orientation. This is being incorporated in the electronic flight information system in most modern and glass cockpit aircraft. Although an important application of science in flight, gyroscopic instruments cannot be relied on exclusively.